Today we're going to learn about the change of base rule for logarithms. So change of base rule says that log a to the base b can be written as log a to the base c divided by log b to the base c. So it's pretty simple. So let's take an example of log 2.5 to the base 2. Normally if you see a calculator, you don't have any button which can find a logarithm to the base 2. We can either find logarithm to the base 10 or natural logarithm. So how do we find it? Let's use change of base rule. We can write this as log 2.5 divided by log 2. This is to the base of 10. So let's use a calculator to find this. So we can write log 2.5 divided by log 2. So we get an answer of approximately 1.32. So how do we verify that the change of base rule is giving the right answer? Let's take a simple example of log 8 to the base 2. So you can write this as log 2 cubed to the base 2. We know the log 8 to the base 2 is equal to 3. So let's verify it using change of base rule. Log 8 to the base 2 can be written as log 8 divided by log 2. So let's calculate it using a calculator. Log 8 divided by log 2 is equal to 3. So we got the same answer as what we know. And let's try it with natural logarithms now. Log 8 divided by log 2 equal to 3. So we know that using the change of base rule, we can find logarithms of any number to any base. So let's try this problem. Show that log y to the base x into log z to the base y into log x to the base z equal to 1. We can easily solve this using change of base rule. Let's write log y to the base x as log y divided by log x into log z divided by log y into log x divided by log z. I'm just applying change of base rule to everything. Log x and log x cancels out, log y and log y cancels out, log z and log z cancels out. So we get the answer as 1. So using the change of base rule, we can easily show that LHS equal to RHS in this problem. We can also solve logarithmic equations. Let's see how to do that. So in this problem, we have to find the value of x. So notice that we have two bases, log 3 and log 1 by 3. First thing, we have to make it the same base. Let's write this as log x squared to the base 3 plus log x minus 2 to the base 3 divided by log 1 by 3 to the base 3. So we know that log 1 by 3 to the base 3 can be written as log 3 to the power minus 1 to the base 3, which is nothing but minus 1 into log 3 to the base 3. So this becomes minus 1. So this entire denominator is minus 1. So we can write it as log x square minus log x minus 2 to the base 3. Now we have to write 2 also as base 3 and make it easy for us to solve the equation. We can write it as log 3 square to the base 3. We know that log 3 square, using the same method as shown above, we can do log, we know that log 3 square to the base 3 is nothing but 2. Okay, let's solve this equation now. Log to the base 3 using laws of logarithm, x square divided by x minus 2 equal to log 3 square to the base 3. So since both the sides have the same logarithm and same base, we can write x square divided by x minus 2 equal to 9. This implies x square is equal to 9x minus 18, or x square minus 9x plus 18 equal to 0. We got a quadratic equation. Let's solve it. Factors of 18 is 6 and 3. And since we need to get minus 9, we write minus 6 and minus 3. And so we can easily say that the value of x is equal to 6, or x is equal to 3. So using the change of base rule and the laws of logarithm, we are able to easily solve this equation.